Hello students, and welcome back to another geometry video. You know what to do. Pause the video, try this problem in your notes, and then unpause it to do it with me. So, this problem is a continuation, or rather a variation of a problem that we looked at in the last video. So if you have not seen the last video, really you need to go watch that video before you watch this one. This one is gonna be a little confusing without the last video. Okay. So, in example 5, the example that we did at the end of last video, a hot dog stand is now located halfway between the shoe store and the pizza stop. So, yeah, at point H, so we'll call this hot dog point. And because it's located exactly halfway, that means that the distance between the shoe store and the pizza shop is exactly the same. We already knew these tick marks. Those were given to us in example 5. The park and the shoe store are the same distance away as the pizza shop and the movie theater. So we called the park point P, we called the shoe store point S, we called the pizza shop point Z, and we called the movie theater point M. So now we know that the hot dog shop or stand is exactly halfway between the shoe store and the pizza shop. So that means this. And now we want to show that PH, the length of PH is equal to HM. So PH is equal to HM. Do you believe this? Before we even start trying to show it, do you believe it? Well, let's get a different color. This and this are exactly the same, so I know that PS and PZ are the same, and I know that SH and ZH are exactly the same. So if you put one green and one blue together, that's the same as one green and one blue together. So yeah, of course they're the same. We can see in this diagram that they are the same, but now we need to show it in math talk, in math speak. So, let's see. I'm going to start off. I'm going to leave the greens and the blues here because this helps me. And I'm going to start off by saying, we know that PS is equal to ZM. We were told that. So maybe we were given. We were given that PS equals ZM. They told us that from the get-go. So those green pieces are the same. They told us that. Now the blue pieces, I should not use that color, that's going to get confusing. The blue pieces here, the blue pieces are the same because that's what it means to be a midpoint. If I am at the midpoint, I am at the middle of these two places. I am the exact same distance away. That's what it means to be a midpoint. So, what we can say is, because H is the midpoint of S, Z, between S and Z, that means, that means SH is equal to HZ. So because H is the midpoint, the blue piece is the same as the blue piece. Okay. And now, PH, this whole segment here, is equal to PS plus SH. And HM over here is equal, and here we'll put and, HM is equal to HZ plus ZM. Now, because different color here, because PZ is the same as ZM, instead of ZM right here, I can write PZ, because they're the same. And because, whoops, wrong one. Because SH is equal to SZ, here, I can write SH instead, because they're the same thing. That's that substitution property of equality we talked about 2 videos ago. Okay, so now that means that HM is equal to SH plus PZ, because these are the same. SH is the same as HZ. So I can just swap them out for one another. And hey! Oh, this should not be PZ. Ah. This should be PS. PS. Okay. Because PS and ZM are the same. So I can only swap those out for each other. Okay. But now look at this. PH equals PS plus SH, and HM equals PS plus SH. So, when you put these two together, this means that PH equals HM, because they equal the same thing. Different. Is this gonna look okay? Oh, it is. Yeah. PH equals PS plus SH. So HM and PH are equal to the same thing, which means that they must be equal. Woo! That took quite a bit of thinking. So this is a proof. We just did a proof right here. And I know what you're thinking, like, proofs. No, everybody says proofs are hard and proofs are scary. And this, I'm not gonna lie, this might have been a little bit hard to follow. The important thing is that you understand this. And we talked about this in the last video. If you can understand proofs like this, you can begin to start writing your own. So, if you don't, maybe you're like, I can't do that. I know what you're doing, but I can't do it by myself. That's okay. That is the first step. When I took my very first calculus class, pre-calculus was okay for me. It was okay. It wasn't amazing, but it was okay. And calculus, the teacher would talk, and I'd be like, yeah, I'm gonna take notes. I have no idea what you're saying. And then I'd try the homework, and I would be like, I understand a little bit more what you're saying, but I still have to, like, look at my notes in order to do this homework. I can't do this homework by myself. And then we would do these group quizzes where you could work together, and they were super hard, but you could work together, you could use your notes, and you could ask the teacher for help. That is when the learning finally sinked in for me. So do not expect yourself to understand these proofs right away and to be able to write these proofs right away. It's a process. Don't beat yourself up and don't give up. If you're like, I don't know what's going on here, that's okay. But just don't give up. Keep trying to understand the proofs, and it will get better. I promise. Okay, so that was a problem like we saw in 2.4. Now we are moving on to 2.5. 2.5 is all about proving statements about segments and angles. So we are going to be doing proofs today, which is why the learning target is that you know what proofs are and that you know what properties of congruence are. So, you'll know what those mean by the end of this video. And our success criteria is that you can write 2-column proofs using those properties of congruence we talked about. So you need to be able to write proofs. And 2-column proofs. 2-column proofs are a type of proof, and I'm going to show you what that looks like right now. A 2-column proof is a type of proof that has numbered statements and corresponding. Corresponding means that statement number 1 goes with reason number 1. Statement number 4 goes with reason number 4. That's what they mean corresponding. 4 goes with 4, 1 goes with 1. That's what they mean when they say corresponding. That show an argument in a logical order. I really like 2-column proofs. A lot of people say like, oh, but they're the basic kind of proof. You'll learn how to do real proofs later. Like, no, 2-column proofs are real proofs, and I love them because they show step 1, do this. Step 2, do this. When people write other kind of proofs, it is sometimes really hard for me to follow. And I have a degree in math, and those proofs can be hard for me to follow. But with 2-column proofs, I can see, step 1, you did this. Step 2, you did this. It's so easy to follow. If you follow these steps, you will arrive at this conclusion. And that's what a proof shows, is we start here, and we end here by following all of these steps. And if you follow these steps, you will reach the exact same conclusion. That's what I love about proofs. You can prove anything. As long as you and somebody else are operating with the same assumptions, you can prove anything. And this isn't just for math. This is for, you could do this for life too. You could prove to your parents that you deserve more allowance, or that you deserve a later curfew. As long as you're all operating on the same assumptions, you could prove that. You could prove that, yes, Black lives do matter based on these certain assumptions. You can prove anything that you want to, as long as you have the same assumptions. So what it's up to us to do is to make sure that we really understand the assumptions that we are making. And if we understand the assumptions we're making, then we just have to connect the dots. Okay, so proof, numbered statements, it has number statements. I think the most important part is that it shows an argument in a logical order. And it looks like this. You'll make like a T-table like this, and you have your statements over here, and you have your reasons over here. Every statement that you make must have a reason. You don't get to write anything and just say, oh yeah, sure, that's a thing. Like, no, prove it. If you say that these two things are equal, how do you know those two things are equal? And if I'm talking gibberish, that's okay. We are going to jump right into an example. This example, we saw, was it 2 videos ago, or was it? No, it was just last video. It was just last video that we saw this proof. But then we didn't write a formal proof. We just kind of explained why these two angles were the same. We didn't show a proof for it. And I did that on purpose because I want to show the proof to you today. Last video, I just wanted to show you the reasoning. Today, we're going to put that reasoning into a proof. So, what I'm going to do is I'm going to start my statements. It says to write a 2-column proof. So I'm going to have my statements over here and my reasons over here. Now, statement number 1 will always be what you are given, because you're given something and this is what you need to use. Anytime they give you something, you're going to need to use it to prove whatever you're trying to prove. So we're going to start with the given because we know we have to use it. So the given is that the measure of angle 1 is equal to the measure of angle 3. The reason, and when we say reason, it means why are you allowed to say this? Tell me the reason that the measure of angle 1 is equal to the measure of angle 3. Well, it was given to me. They told me. They told me in the problem. So I can say given. Now, statement number 2. It can be hard sometimes to just see. Oh, I see what step number 2 should be. No, and that's not even math people. We're not like, oh, obviously this is the next step to take. Sometimes, very rarely that happens, but most of the time we're like, step number 2. What might that be? So what I'm going to do is I'm going to go down, what do I want to have at the bottom? At the bottom of my proof, last step, what should it be? Well, we are trying to prove this. We are trying to prove that the measure of angle DBA is equal to the measure of angle EBC. So in the end, I want to have this. Now, in order to get here, I need to take steps from here to here. I need to connect the dots between the measure of angle 1 and the measure of angle 3 being the same, and the measure of angle DBA and the measure of angle EBC being the same. So, I'm gonna look at my diagram. Looking at your diagram is a beautiful, beautiful thing to do when you're doing a proof. Yeah. I'm a color coder, I'm a picture kind of person, and even if you think you're not a picture kind of person, this will help your proofs. Even if you could do the proof without it, the picture makes it easier. So let's look at our picture. And we have DBA. You might remember this from last video. DBA is this red angle here, and EBC is this red angle here. Now, what we talked about in the last video is that angle number 1 and angle number 3 are the same, and angle number 2 will always be the same as itself. So, here's what I'm noticing. I'm noticing that the red angle, the measure of angle DBA, is equal to, so the red angle is angle number 3 plus angle number 2. Yeah. Okay, cool. So now I'm starting to see a connection. See how here I have angle 1 and angle 3, down here I have DBA and EBC, and then look at step number 2. I have measure of angle 3, I have part of the first step in here, and I have part of the last step in here. So you can see how it's like, you're like connecting the two. We're going from step number 1 to the last step. Okay, so we know this is true. Whoops. We know that the red angle is equal to angle 2 and angle 3 put together. Now let's look at the blue angle, because the red angle is down here, but the blue angle, I don't see that in my steps on the way down. So, let's look at step number 3. Oh, wait a minute. We almost forgot to give a reason. What is the reason that I can say the measure of angle DBA is equal to the measure of angle 2 plus the measure of angle 3? Why am I allowed to say that? We can see in the diagram, like, duh. I go from one ray to the other ray, to the opposite ray. I'm going across angle 2 and angle 3. But remember, this was the angle addition postulate. This was the angle addition postulate that said we could do that. Okay, now we move on to step number 3. Okay, and in step number 3, let's take a look at the blue angle. So the blue angle is measure of angle EBC is equal to the measure of angle 1 plus the measure of angle 2. Now, why am I allowed to say that? Same reason I was allowed to add the two red angles together. Because of the angle addition postulate. Okay. And now, step number 4. Let's see. Have I used this yet? I wrote it in my proof, but have I used it to help me? No, I haven't. I just wrote it there. I just wrote it in step number 1, but I need to use it. If they gave it to me, it means I need to use it. So, DBA is measure of angle 3 plus measure of angle 2. EBC is the measure of angle 1 plus the measure of angle 2. But wait, the measure of angle 1 and the measure of angle 3 are the same. So, I'm allowed to say that the measure of angle EBC, we'll just go EBC, is equal to the measure of angle 3 plus the measure of angle 2. And why am I allowed to do that? Well, because angle 1 and angle 3 were the same. So I just substituted, instead of writing the measure of angle 1, I wrote the measure of angle 3. That's all I did. Let me erase these black lines, are getting confusing. So instead of writing the measure of angle 1 up here, I just wrote the exact same thing, but instead of measure of angle 1, I wrote the measure of angle 3. And that's just substitution. I substituted angle 1 for angle 3. So substitution property of equality. Do you need to write property of equality? If you just wrote substitution, I would know what you're saying. But substitution property of equality is the official fancy name for it. But if you can just write substitution. If you're in my class, you can write substitution and I'll know what you mean. Okay. Now, check this out. We have the measure of angle DBA equal to angle 3 plus angle 2. And I have the measure of angle EBC equal to the measure of angle 3 plus the measure of angle 2. This is the same, which means that these are the same. So now I can say, yeah, I can say the end. Now I can say the end. Measure of angle DBA equals the measure of angle EBC because this is just substitution again. Up here, DBA is equal to measure of angle 3 plus measure of angle 2. So here, I can swap this for the measure of angle DBA. And I have measure of EBC equals measure of angle DBA. So this is just substitution again. That 5 looks fine. This is substitution yet again. Now, how do you know you're done? When you do a proof, how do you know you're done with the proof? Well, we wanted to prove this. In fact, let me highlight this. There's so much going on here. We wanted to prove this. Our last step showed this exact statement, and it gave a reason. So when you have a reason for your last step, and your last step is what you wanted to prove, you're done. Because you've proved what you wanted to prove. So think of when you see a problem like this, where it says write a proof, think of your given as your starting point, step number 1, and think of the prove, what it says to prove, think of this as your end, or your finish. So the given will always be at the start of your proof, and what you're trying to prove will always be at the end of your proof. So that's how you know when you're done. Okay, let's check our answer. And, okay. So they did it in a tiny bit different of order than us, but this doesn't mean that we got it wrong. Just because they did this before we did, doesn't mean that we got it wrong. It just means that they did it in a different order. Our proof, even though it doesn't look exactly the same, is still valid because we used logic and reasoning. We did the same stuff as them, just in a little bit different of an order. And that's okay. That's the beauty of math. Okay. But yeah, they had DBA is measure of angle 3 plus measure of angle 2. They substituted, they wrote, so these, notice how step 2 and step 3 are the exact same, except instead of writing angle 3, we wrote angle 1. And that's substituting this right here. Measure of angle 1 is the same as the measure of angle 3. And then, they knew, yeah, they had EBC is equal to 1 plus 2. Angle addition postulate, we did that too. But then you have different color. They have this, and they have this, and see how both of them are equal to the measure of angle 2. So that's why you're allowed to just, oh, transitive property of equality. You could say the transitive property of equality, you can also say substitution. Both of those work. But yeah, both of those work. If this is confusing to you, you can just say substitution. Don't worry. Don't even worry about it. Okay, cool. Beautiful. We got those right. That feels good. So next, some important information. We saw these in the last video, the reflexive, symmetric, and transitive properties. But now I want to show you what they look like with segments and with angles. So we saw in the last video, they had example of like what it meant in words, and then they had like examples of segments and angles. We saw that back in the last video. But now we're going to go into a little bit more detail about it. So, what does the reflexive property look like for a segment? Well, if you find yourself saying that segment AB is is congruent to segment AB, that's the reflexive property. Because you're saying that one thing is congruent to itself, and that's the reflexive property. Remember, it's like you're looking in a mirror and seeing yourself. AB is looking in the mirror and seeing itself. The same goes for angles. If you ever see angle A is congruent to angle A, that's the reflexive property again, just with angles. Okay. Different color. Symmetric. You might see the pattern by now, but you might not. So I'm going to keep explaining in case people need more explanation. If you see AB is congruent, segment AB is congruent to segment CD, and then I can flip them and write the same thing. Segment CD is congruent to segment AB. Remember, that's just flipping it. That's the symmetric property. Like A equals B, if A equals B, then B equals A. That's the same thing, I'm just flipping it. So that is the symmetric property. And the exact same thing goes for angles. Angle A congruent to angle B, angle B congruent to angle A. You're just flipping it. That's still the symmetric property. And lastly, the transitive property. If AB is congruent to CD, CD is congruent to EF, then AB is congruent to EF. So it's like you're hopping from AB to CD, and then you can just hop straight to EF because CD is equal to EF. So that is the transitive property. Just like we said, if x equals 3, and x equals y, then y equals 3. This is the exact same thing, just with segments instead of x's and y's. Okay. Now, the same thing goes for angles, of course. Angle A congruent to angle B. Angle B congruent to angle C. Well then, A was just congruent to C in the first place. It's like if you just cut the B out of this. If you just take the B or the middleman out, look at that. A is congruent to C. That's another way you can think about it. So that is the transitive property with segments and with angles. So now, we're going to see an example where we are going to name properties of congruence. So what happens if you see something like this in your proof? If you see something like this in your proof, what would the statement, what would the reason be? This would be your statement. What would the reason be? Well, T congruent to V, V congruent to R, then T congruent to R. So T congruent to R. Ah, this is the one where I'm hopping around. This is the one where I can cut out the middleman. This is the transitive property of congruence. Okay. Now, you don't have to write transitive property of congruence. You can just write transitive property if you're in my class. Your teacher might want you to write of congruence. So check in with your teacher, but if you're in my class, transitive property will be just fine. Okay, let's get rid of those markings so that we can read the second problem. So this might be a statement that we would see in a proof, then what would the reason be? So JL congruent to YZ, YZ congruent to JL. Ah, so this is the same thing, they just flipped it around. So this is the symmetric property of congruence. Again, you don't, in my class, you can just write symmetric property. You don't have to write of congruence, but cool, let's check and see if we were correct. Transitive property, of angle congruence, getting even more specific, and symmetric property of a segment congruence. You can get even more specific. I know what you mean. I know we're talking about segments, so you don't have to say segment congruence for me. But if you want to, by all means, go for it. Okay. Example 4, writing a 2-column proof. So first thing I'm noticing, I don't have a diagram. Diagrams severely help me with proofs. So the first thing that I am going to do anytime I have a proof is make sure that I have a diagram I can look at. So, prove this property of midpoints. Okay, so we're dealing with midpoints. If you know that M is the midpoint of AB, okay, let me write this down. I have AB, and M is the midpoint, is what they're telling me. Which means, if M is the midpoint, it means that it's halfway between A and B. It means that these segments are congruent. That's just the definition of a midpoint. We know that. So I can put these tick marks on my diagram. So if I know that M is the midpoint of AB, prove that AB is 2 times AM, and AM is 1/2 of AB. Okay. So another thing, remember how we talked about when we make our statements... Whoops. Ugh. When we make our statements and our reasons, I'm supposed to start with the given. But it doesn't say, right? Normally it says, given this, prove this. They didn't tell us that, so we're going to have to write that down for ourselves. So, I noticed that it says, if M is the midpoint of AB. So that's what we're given. They're saying if M is the midpoint of AB. We are assuming that M is the midpoint of AB. So that assumption we're making is what we're going to call the given. M is the midpoint of AB. But what does that mean in math speak, right? I could just write M is the midpoint. I could write that. Or I could write it in math speak, like we did on our diagram. What it means for M to be the midpoint is it means that M is halfway between A and B. It means that AM is the same as MB. So we can write that in our given. Our given is that AM is equal to MB. Notice how I didn't say congruent. I didn't do that. Because we know that the length of AM is equal to the length of MB. So I'm not putting any lines above the top. So that's what we're given, because M is the midpoint of AB. Okay, now what are we trying to prove? Well, it says right here, prove that AB is 2 times AM. Let's put that in math speak. AB is like equals, 2 times AM. And AM is 1/2 of AB. Okay, and let's draw a little border so I can keep my picture separate from what we're trying to prove. Okay, cool. Now I know what I'm given, what I'm trying to prove. So, first step is writing down the given. Now, our reason here can be given. We can also say that this is the definition of a midpoint. Oops. Definition of a midpoint is that's the point that cuts the segment in half, that makes two equal pieces. Okay. Now, step 2. Again, step 2 is not super obvious to me, and if you think I'm just the teacher up here that's like, oh, we do this, and then we do this, and then we do this, I gotta think through proofs just like you do. So if you're like, man, I have to think really hard about this, that's normal. I'm also thinking pretty hard about this. So don't think that you're not as smart or that you're not as good at proofs if you have to think a little bit harder. In my college days, we had classes where we had to go up to the board in front of everybody else in the class and prove something. And then everybody sitting in the class got to say, that's wrong, that doesn't make sense, you did the proof wrong. And you're just like, okay, I'll fix it. Like, so I know about the anxiety around proofs. Don't worry, I'm not gonna make you go up in front of everybody and prove something. I'm not gonna make you do that. So, we are trying to prove. Remember how in the very first example, I put what we are trying to prove? Now, we don't know what number of step it is, but I know that in the end, I want AM, let's see, AM equal, oh yeah, I have more space. Whew. Thank goodness, because we gonna need it. In the end, I have AM equal to 1/2 of AB. That's one of the things I want to prove in the end. I also want to prove that AB is equal to 2AM. And I just took that right up here where it says prove. I just wrote that at the very end. So those are the things that we want to get to. So how could I get from here to here? Well, here I'm noticing that we talk about AB, but up here I don't see any AB. So that's a step that I need to take. Maybe step 2 could involve AB. So step 2 is going to involve AB. Now, what do I know about AB, though? What could I possibly write here? Let me look at my diagram. What do I know about AB? Oh, well, I don't know if this is going to help, but one thing that I see that I know about AB is that it is equal to AM plus MB. Right? 2 chunks added together make up the whole chunk. And this is the segment addition postulate. Do not forget to write your reasons. Your reasons are what makes a proof a proof. The reason is what says, I can say this because of this. So nobody can argue with you. That's what a proof is. A proof is an argument that if this, then this, and that nobody else can argue with. Your argument is so solid, nobody can tell you you're wrong. That's what it means to write a proof. Okay, cool. So I know this, and remember how I said I don't know if it'll help? A lot of the times when you're writing a proof, you do this. You say, okay, I need to know something about AB. What could I possibly write down about AB? Well, this is one thing I could write down about AB. And then you try some stuff and you go, okay, wait, that didn't work. Okay, so let me go back. That didn't work. Let me go back and find something different about AB. What else do I know about AB? And then you try that, and maybe that does work. So if you ever do the wrong thing in a proof, don't give up because you did something wrong. Do you know how many proofs I've gotten wrong? Do you know how many times I've walked up to the board in front of an entire class and they've told me, that proof is wrong. Or you did way more work than you need to do. This proof was way easier than you made it. Sheesh, sorry. Don't worry about it. Don't worry if you mess up during a proof. That's the whole process of a proof, is you're gonna mess up, or you're probably gonna mess up, and that's okay. That is okay. Okay, so now what? Let me see if I can use this. AM plus MB. Now, I haven't used my given yet. I haven't used this. AM is the same as MB. Oh, wait a minute. I wanted to show that AB is equal to 2AM. That's the same thing as AB equal to AM plus AM, right? 2 AMs is just AM plus AM. But look at this. Here, let me highlight it. This is the exact same as this, only the MB has turned into an AM. But I can do that. I can turn an MB into an AM because they're the same. AM and MB are the same. Woohoo! This is wonderful. This is a fantastic breakthrough. Okay. So yeah. Yeah, let me just write that a little bit more clearly. Step 3 is AB equals AM plus AM. And this is substitution. AM equals MB, so instead of MB, I'm just writing AM. So this is substitution. Property of equality, I'm just going to write substitution. And then now look at this. I can just say step 4. I can go right to AB is equal to 2AM, and this is just simplifying. This is literally just AM plus AM is the same as 2AM. So all I'm doing is simplifying. Your reasons don't always have to be some fancy postulate. Sometimes your reason will be the segment addition postulate, or the transitive property of congruence. Sometimes it'll have this fancy name, and sometimes it'll just be simplify. As long as you give a reason for what's over here, you're good. As long as you give a reason, you're good. It doesn't need to be something super fancy. Okay. Now, cool, I proved half of what I wanted to prove, I'm done with. I did that. I did the first part. But now, somehow, I need to get from here to here. AB equals 2AM. Wait a minute. What if I just divide? What if I divide by 2 on both sides? Then I get rid of the 2, right? Because down here I wanted AM by itself. So let's just try to get AM by itself by dividing 2 on both sides. Then I get 1/2 of AB, or AB over 2, it's the same thing, right? 1/2 of AB is the same thing as AB over 2. This is algebra, that's the same thing. Okay, so 1/2 of AB is equal to AM. And look at that. That is the second thing that we wanted to prove. It's written in the opposite, in the mirror image. It's AM equals 1/2 of AB, but it's still the same thing. Woohoo! So what's our reason for this? Why was I allowed to go from step 4 to step 5? Why was I allowed to do that? What did I do? Well, I divided by 2, and I'm allowed to divide the same thing on both sides because of the division property of equality. But again, if you write division property, I'll know what you mean. Cool! We proved both things that we were trying to prove. So we're done. And we have a reason for every one of our statements. So we're done. Let's check our work. We combined steps 2 and 1. They wrote them as 2 different steps. That's okay. Oh, they added this step, so we took that step out, but that's okay. Segment addition postulate, substitution property of equality, They didn't put the simplifying step in there, but that's okay. And then division property of equality. Woo-hoo-hoo-hoo. Beautiful. Beautiful. Feels good to finish a proof. Feels good. Okay. If you have questions after this lesson, that's normal. It was a longer video than usual, and it was packed full of proofs and a lot of deep thinking. So if you have questions, that's normal. Questions are good. Just make sure that you get them answered. Ask your teacher, ask a friend, talk through these proofs with a friend. Make sure that you understand the proofs that we did here today. Now, if you would like some practice problems, yeah, there's only one page of practice problems. All of these, this is like example 1, this is like example 2, and this is like example 4. So, try these problems if you'd like to hone the skills taught in this video. But remember, still do the homework that your teacher assigned. Alright, and as usual, we're going to end our video with a launch. So, this launch comes from Jennifer Lopez, and she says, "You get what you give." This is kind of like karma, right? If you're a bad person, bad stuff's going to happen to you. If you're a good person, good stuff will happen to you. But that's not always true, right? Sometimes really good people just have really bad stuff happen to them. What this means is that if you give kindness away, you're more likely to get kindness from other people. If you give a bad attitude and sass to everybody, you can expect to get a bad attitude and sass from everybody. If you're rude to other people, you can expect them to be rude to you. That doesn't mean that you're not allowed to mess up, but when you mess up, you should apologize. If that's what you want from other people, if you want other people to apologize to you when they mess up, you should do the same. And it's not that because you apologize to other people, now you can expect them to apologize to you. That's not what this is. But be the change you want to see in the world. If you want kindness, give it away. You can't just sit around and wait for people to be kind to you in order for you to initiate some kindness. So, give what you want to get back. And you might not get it back, but at least you gave it and you started trying to make the world a better place. So, that is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day. And thanks for being here. Thanks for watching. Bye.